Hello Year 12 and welcome to our next video here for a new topic, trig equations. We've done some trig equations before. We're going to come back through and look at some harder ones, I suppose. And I'm really going to rely on you being familiar with a whole lot of these formulas and identities that we've learned in the past. So let's just quickly skip past compound angle formulae, right? Sine alpha plus beta, sine alpha minus beta, same with cos, the same with tan. They're going to help us with some substitutions. The double angle formulae, just an extension of that, corollary of that, I suppose. The T formulae, we're probably not going to use in this first exercise, but you still need to be familiar with these. They will form an important part of a later exercise. Products to sums, rearranging those compound angle formulas, rearranging these into these couple of forms here, so sine alpha, cos beta, cos alpha, sine beta, and so on. They're helpful, and this new one here, these cos 2 theta, just an arrangement of that double angle formula before, rearranging those, but these can be a helpful substitution where we find ourselves with the cos squared theta or a sine squared theta, and I want to try to make everything in terms of 2 theta. Okay. Now that's because, generally speaking, when I have a trig equation that I'm trying to solve, I want to get all the angles the same, and then all the trig functions the same. Okay. So once I've got that far, then it's probably fairly solvable. There's quite a few examples to go through here, and they'll take a little while. So let's get stuck into those. I have an equation here. It's asking me to solve it 2 different ways. To begin with, using the ratio identities, and we'll remember that tan is sine over cos, and sec is 1 over cos. So for part A here, 2 tan theta, if 2 tan theta equals sec theta, then we could say that 2 sine theta over cos theta equals 1 over cos theta. Multiplying both sides by cos theta, and I get 2 sine theta equals 1, instead of cos sine theta equals 1/2. And if I'm after answers between 0 and 360 degrees, then sine is positive in the first and second quadrants. The sine of 1/2, draw your little triangle quickly if you need. Okay, 1 here and 2 here. So sine is 30 degrees up here. So theta is 30 degrees, or 180 minus 30, 150 degrees. Okay, so that was using the ratio identities. 2, right, we didn't need to change any of the angles theta were the same throughout, but I did that and I reduced everything down to being a sine function. We got rid of the tan and the sec, and made everything sine. Now for part B here, we're going to square both sides and see what happens there. So, I'm going to have, let's jump straight into this. So instead of 2, I'm going to say I've got 4 tan squared theta equals sec squared theta. And from here, we might remember that sec squared theta, right, sec squared theta equals 1 minus tan squared theta. Rightio. So, just sort of a little aside here, if I remember that sine squared theta plus cos squared theta equals 1, if I divide everything by cos squared, right, sine squared over cos squared is tan squared theta, cos squared over cos squared, so tan plus 1 equals sec squared theta, right, 1 over cos squared. So I'm going to replace my sec squared here with 1 over cos squared. 1 with 1 plus tan squared, or tan squared plus 1. So 4 tan squared theta equals tan squared theta plus 1. That means that 3 tan squared theta equals 1 means that tan squared theta equals 1/3 means that tan theta equals 1 over root 3. Back to our little triangle over here. Right, 1 over root 3, tan is 30 degrees, but, oops, that's plus or minus there. So therefore, theta equals, now, tan, because I've taken the square root there, I get a plus or minus, and so that means I've got answers in all 4 quadrants. We're after a solution between 0 and 360 degrees. However, if I come right back to the question here, 2 tan theta equals sec theta, right, then tan and sec must have the same sign, or if you like, tan and cos must have the same sign. That's true in the first quadrant. It's also true in the second quadrant. Right? They're both negative in the second quadrant. In the third and fourth, they're different signs. So even though I'm after solutions between 0 and 360 degrees, I'm only interested here. The only ones that will make this true will be the first and second quadrant. So I get 30 degrees and 150 degrees again. I think probably the ratio identities was a simpler way to do that one. Anyway, let's look at another example. Tan 4x minus tan 2x. I'm going to use the tan 2 theta formula. Right, well the tan 2 theta formula is 2 tan, hang on a tick. I'm going to get 2 tan 2x over 1 minus tan squared 2x. Rightio. So, 2 tan 2x over 1 minus tan squared 2x. Okay, so if we consider theta to be 2x, then 2 theta will be the 4x. So that's our tan 4x there. So this equals negative tan of 2x. Multiply throughout here and I get 2 tan 2x equals negative tan 2x plus tan cubed 2x. And rearranging these things a little more, I'm going to say I've got, let's say tan cubed 2x minus 3 tan 2x equals 0. We'll factorise. I'm going to take a tan 2x outside of tan squared 2x minus 3 equals 0. I'm going to have to switch my working over this side now. So, that means that either tan 2x equals 0 or tan squared 2x equals 3, which means that tan 2x equals plus or minus root 3. Okay. Now we need to adjust the domain here because they're both 2x's. So if 0 is less than or equal to x is less than or equal to pi on 2, then 0 will be less than or equal to 2x, be less than or equal to pi. Okay, that's just a reminder which answers we're after here. So, between 0 and pi, when is 2x, when's tan 2x equal to 0? Well, tan produces 0 at 0, pi, and 2 pi. So I'm going to say 2x equals 0, pi, 2 pi, or x equals 0, pi on 2 pi. Now over this side here, if tan 2x is plus or minus root 3, that means that my angle is, for tan equals root 3 will be 60 degrees, or pi on 3. So this means that 2x equals, now, pi on 3 is our related acute angle. Again, this is going to take in all 4 quadrants. So pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3 means that x is, right, I might just add it to the ones over here. Oops, not what I meant. So I'm going to have pi on 6, pi on 3, oops, wait, yes, pi on 3, 2 pi on 3, and 5 pi on 6. A lot of answers there, isn't there? Rightio. Reflection there, I thought I had too many answers. I have extended my my domain too far here. Only to pi was I after to begin with. So 0 and pi, not this one here. Of course, that's too big. Pi on 2 is my biggest possible answer. So 2 pi on 3 is too big. And so is 5 pi on 6. Oops, got to be a bit more careful there. Rightio, so those 4 solutions. Right, I should get rid of these ones. Oops, get rid of these ones here. And that was using the tan 2 theta formula to produce those answers. Rightio, 4 solutions. Next up, I've got this equation here. And what are we going to do here? We're going to change all the angles to x. So remember, try to use all the same angles. And after that, try to use all the same ratios. So for part A, let's change my cos 2x. Now you might remember that cos 2x, you can go back and refer to things there, is cos squared minus sine squared. So cos squared x minus sine squared x equals 4 sine squared x minus 14 cos squared x. Rightio, now we can tidy these up a bit, and I'm going to get 15 cos squared x equals 5 sine squared x. This is coming together nicely. Let's say 15 over 5 equals sine squared over cos squared. Okay, just to remind us, because sine squared over cos squared is tan squared x. So we've got tan squared x equals 3. Tan x is plus or minus the square root of 3. And that means that x will be, after answers from 0 to 2 pi. So pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. Rightio. That was change everything to x. What if I'd go the other way and change everything to 2x? So that means that I've got cos 2x. Now, my sine squared, remember these new formulas I said, sine squared is half minus half cos 2 theta, or 2x in this case. So equals 4 outside of half minus half of cos 2x, and the minus 14 outside of, now cos squared was half plus half cos 2x. Yeah, keep moving along here. We'll expand those out. Cos 2x is 2 minus 2 cos 2x minus 7 minus 7 cos 2x. Rightio. I'm going to have 9. I'm going to have 10 cos 2x equals negative 5. Cos 2x equals negative 1/2. Now, for my range, if 0 is less than or equal to x, less than or equal to 2 pi, make sure I get it right this time, 0 is less than or equal to 2x, less than or equal to 4 pi. Right, make sure we pick up all the possible solutions here. Therefore, right, so cos being negative, right, for cos to be negative, it needs to be second and third quadrant. So I'm going to have 2 pi on 3, right, my related acute angle is pi on 3, inverse cos of 1/2. So 2 pi on 3 and 4 pi on 3. Right, they're my second and third quadrant angles. But also if I make a full revolution again, because I've got up to 4 pi, right, so another 6 pi on 3 here, I'll get 8 pi on 3, 10 pi on 3. Oops, I should say in here. It's a bit sloppy. So we're going to say here 2x equals this, for x equals the half of each of these, which is, of course, pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3, just as we got previously. Rightio? So, two different ways to solve the same question. One more example here, before your brain falls out your ears. Homogeneous equations. Now, in this case here, right, I can have a number of terms in my equation. I need to be able to represent each of those terms. Remember, there's a bit separated by pluses or minus signs. With the same number of sines and coses, in a sense, combined together. So, sine cubed has the same index, if you like, as cos cubed, or sine by cos squared, or sine squared by cos, so on. Rightio, so I need to have sort of the same number of sines and coses if I combine them together in each term. Keeping in mind that things like 1 I could rewrite as sine squared plus cos squared. And any double angles I could again use a formula to rewrite that in index form. Once I've done that, once everything's in terms of sine and cos, then I divide throughout by the sort of highest power of cos, and that will turn everything into 10. I'll show you how that works here. So I've got sine 2x plus cos 2x is sine squared x plus 1. Now, if we remember, the sine 2x is 2 sine x cos x. Right, so you might need to keep going back and referring to your notes while you're doing these, and remember you get a reference sheet during an exam as well. So we've got 2 sine x cos x. Now cos 2x is cos squared minus sine squared. So plus cos squared x minus sine squared x equals sine squared x. Now plus 1, I'm going to say is sine squared x plus cos squared x. Certainly seems to have been making life difficult here, but we can collect a fair few terms here. So if I look at the sine coses, that's it. Cos squareds, one on each side, they can cancel out. Sine squareds, I'm going to have 2 sine x cos x minus 3 sine squared x equals 0. Now I'm going to divide everything by cos squared. So let's write this 2 sine x cos x over cos squared x minus 3, like this, sine squared x on cos squared x, and 0 divided by anything is still 0. Now, here the cos cancels. And I'm left with 2 sin x on cos x, which is 2 tan x. And here, minus 3 tan squared x equals 0. From here we'll factorise. I'll take a tan x outside of 2 minus 3 tan x equals 0. Therefore, tan x equals 0. It means that x equals 0, pi, or 2 pi, or tan x equals 2/3. In which case here, right, this is a bit fiddly here, we have to pull out the calculator. Because, check that we're in radians, right, because I am providing x in radians, the inverse tan of 2/3. So, I'm after a positive answer, so tan will be positive in the first and fourth. So, let's go inverse tan of 2/3. Approximately equal to, what was that number again? 0.588. Okay, so that's the first quadrant answer. The third quadrant solution is going to be that number plus pi. Grab the calculator again. It's a plus pi is about 3.730. Rightio, so getting a bit scruffy there because we didn't have an exact value. Rightio, there's a huge amount of technique in all of that. We'll spend a few lessons going through it, I reckon. If you've got any questions about any of those things, if I've made a mistake, and there's a very high chance I have, make sure that you let me know and enjoy that. Other than that, I'll see you in class. Thanks, guys.